You're going to be sitting.
Hey, everybody. Take this thing off. All right. It's just around 9 o'clock now, so we're going to go ahead and get this kicked off. We'll probably have more people coming in and out as we go here, but I'd first of all like to say welcome and thank you for attending. This is our second installment of the LC University that we put on. So 2 weeks ago, did our first one, which was on the Easy Command, and had it well attended. And we expect probably to break that record here today with attendees. So appreciate you all joining us and participating. For now, we do have everybody muted. There'll be times where we'll stop and you guys can ask questions as we go. But the other piece that we did, and part of the reason, again, I apologize right now in advance for the second invite that we had to do. And that was because there were some features within Teams that we wanted to go ahead and implement here. One of those being the chat function. The chat function wasn't working in the last version of this that we had. So now on your screens, I'm just going to quickly share my screen to do a little bit of training here on Teams in case you're not familiar. So if I bring up my screen here in Teams, so hopefully y'all can see my screen. These three dots here where it says more actions, if you click on that, there's a couple things here. One is we had a lot of requests for turning on the live captions, the closed captioning on the screen. We can't do that from here for everybody, but you can individually do that from your PC if you're using the actual Teams application. If you came in through a browser and you're just doing it over the web, you may want to at some point get the actual Teams application and get onto the meetings through Teams, because once you do that, you have this option here to turn on live captions. So if we speak quickly or you're having a hard time understanding everything we're saying, you can turn on the live captioning, and that will give you the ability to see on the screen, and it does a really good job of interpreting what you're saying. So that's one thing, the option that's new to this Teams environment that we have today. The other thing is up here in this corner here is a chat conversation piece. So when you click on that, you should be able to also then add and converse and type messages to us. And as our two presenters today are presenting, you'll be able to chat information over, and I will try and address those depending on how quickly they're coming in. Myself, if there's a question that maybe is too complex to answer in a chat, we'll answer those, as we get a break or towards the end of the class here. So keep in mind, if you have some grandiose question here, we may just hold off until one of those sessions to where we can answer it and give it a proper answer. So a couple other things before we kick off the training. We did change things up a little bit here. So in May, we do have 2 trainings coming up. Again, these trainings are going to be every other Wednesday. So 2 weeks from now, we'll be having training. Again, it will be similar to this, but more commercially focused. So if you have people on your sales team, the first one's going to be about the metering principles, and the second will be about the PD meter itself and talking about applications and things like that. So when we did the sign up for this class, we had a lot of people asking for some application training. So we're going to invite in some of our regional sales managers to come in and do those trainings specifically in May. So pretty excited about that. We're also, after last week's Easy Command training, we're going to do a workshop on Easy Command, different than what we did in the last presentation. And this will be a small group open to about 20 people. To where we'll actually get on through an application called Splashtop, to where we can work with each one of you over your PCs. And the idea of that class will be for technicians that want to have or don't have Easy Command operating on their laptop today. There's some prerequisites for that course. So when the invite comes out for that class, pay attention to that. You'll need to have a PC, a special cable, and some other things. But again, more geared towards actual technicians, people that need to have Easy Command running on their PCs and maybe are having an issue. So the object of that class is everybody who leaves that class will have Easy Command operating on their computer once it's done. See, I covered chat, I covered closed caption. Let's see, I think that's pretty much everything I wanted to cover. So With that, I'm going to go ahead and hand this session over to Tom Planowski, who is one of our seniors technicians here at Liquid Controls, and he's going to walk us through the PD meter principles. So again, thanks everybody for joining us. Oh, I didn't introduce myself again. If you don't know me, I think most of you do. My name is Jeff Hageman. I'm the Service Operations Manager here at Liquid Controls. And today, our technicians, Tom Planowski and Juan Valencia, will be walking us through the PD meter principles. So again, thanks everybody for joining us, and I'm going to hand it over to them.
Hello guys, this is Tom Planowski. I'll try to switch the view to my presentation and we'll start. Hopefully everybody can see clearly.
I can see it, Tom.
Okay, good. All right, so again, good morning and good afternoon and good evening, depending where you are in the world. My name is Tom Planowski and I'm service technician. The topic of today's training is LC positive displacement meters. But to be more specific, we'll really cover two areas. First one is a basic principle of operation of LC tri-rotor design meter. And we'll also cover things like installation, operation, startup, and maintenance of the meter. We want to make sure that when the meter is put in service, it operates properly and lives up to its reputation of longevity and precise measurement. The second part of the training will be done by Juan Valencia, my colleague, and it's really going to be a live demonstration of taking meter apart, disassembly of a meter, looking at some of the components, pointing out some details of a design, maybe details of repairing if required, and then reassembling meter back together. That's going to be a second part. We'll take a break in between. Liquid Controls started manufacturing meters in 1950s. In 1956, the first meter was sold. It was model M60 sold to United States Air Force. Ever since, we obviously manufactured a lot of meters and designed a lot of meters. Meters have changed. We designed different sizes of the meters, different applications. We introduced a line of accessories to complement those meters and lines of mechanical and electronic registration. The one thing that has really not changed in all these years is a basic principle of how the meter works. On this screen, you can see a very, again, basic cross-section of our meters, and that's where you can see that principle of tri-rotor design. We have a housing, and a housing has three cylindrical bores. They're precisely machined inside of the housings, and three rotors are inserted into those housings. In one of my trainings years ago, it was a live training with a customer that has never seen Liquid Controls meter. They were used to different designs and different technologies. And when we took this meter, our meter apart, it was actually M30 meter, 4-inch meter. First reaction that I received was, that's all it is. That's all it's inside of that meter. And if you look at this exploded view of the meter, there's not a lot of parts in it. It's exactly 9 parts in it. So we have our housing. And again, housing has cylindrical bores inside of it. They're precisely machined. And then you have 3 rotors. The larger rotor, it's right here. It's called a blocking rotor. And 2 identical smaller rotors, they call displacement rotors. Those 3 rotors are supported on each side by 2 bearing plates. On the end of the rotors, we have 3 gears. On the end of the blocking rotor, we have blocking rotor gear, and on the end of the displacement rotors, we have two displacement rotor gears. The main purpose of the gears is to create timed or synchronized relation between three rotors. So when they turn together. Now this little video will show you how those rotors really move inside when they're put in motion. Let's see. All right. So you can see, and I'll restart this. Sorry. What you can see is the blocking rotor turning one direction and two displacement rotors turning in opposite direction. The displacement rotors, because the displacement rotor gears are twice the size of the blocking rotor gears, the displacement rotors are turning twice as fast as the blocking rotor. So again, I'll put it in motion one more time. All right. So the 9 components that you see inside of the meters, the housing, the rotors, the gears, and 2 bearing plates, create what we call metering element, or in some people will call it measuring chamber. So 9 components make the whole meter. Now, our meters are called dual case meters. So on the top of the metering elements, when you have your meter body, we also have external covers. You have a front cover, and you can see it here, and a rear cover. The covers and the body provide or create pressure-containing vessel. When the liquid is introduced to the meter through the inlet side of the meter, it starts filling up the meter, but also it will fill up those covers. In this little picture, you can see on one side of the housing, there's small notch in a housing. In some of our meters, you're gonna see 2 holes. It's a bleeding holes or bleeding notch, allowing product when it's entering the meter, fill up those covers. What that's providing us, it's providing hydraulic balance inside of the meter. That means the bearing plates are exposed to equal pressure, and that prevents deflection or bending of the bearing plates. That also helps to keep internals of the meter centered inside of the meter. If the bearing plates are not bending, not deflecting, that obviously helps us to maintain clearances inside of the meter, helps us to maintain ultimately accuracy of the meter. Now, what makes the meter turn? The meter doesn't turn on its own. It's usually going to be a fluid that moves through the system that's going to make the meter turn. And movement of the fluid is generally generated by pump pressure in most cases, or in some cases through the gravity. A liquid controls meter is going to work with either gravity or pump pressure. So as the liquid moves through the meter, the rotors will turn, and they will turn in synchronized motion because, again, of the timing gears. As the liquid, and you can see it on the screen, as the liquid is entering the meter, it encounters the blocking rotor and then follows the displacement rotor through the housing. As the liquid moves, it gets broken into uniformed sections. So it's divided into sections inside of the meters. And you have a liquid that enters the meter and leaves the meter simultaneously. Now, since the volume of the bores inside of the meter is known, and the same amount of liquid will pass through the meter during each revolution of a blocking rotor, based on that, we can determine the volume of the liquid that goes through the meter and determine that value with high accuracy. I think one of the points that's really important in this statement is that the same amount of liquid passes through the meter. What it really means, and it's really a basic requirement for proper operation of the LC meter or really any meter, that meter has to be full of liquid. This is something you're going to hear from me probably multiple times, and something you're going to hear from other guys in a different occasions, that the meter will measure accurately if it's full of liquid at all time. Because if it's not full of liquid, what is it really measuring? Well, most likely it's measuring air. Most likely, depending on application, could be measuring a vapor, but it's definitely not measuring a liquid. So going forward, when we talk about accessories to the meters, when we talk about applications, it is important to make sure that the air is being considered as an important part and how we deal with the air in the system. But that's in the future. The other part that's really important to this view is not only that we have meter full of liquid, but also that the sections of the liquid that's being created inside of the meter are separated from each other. That the liquid doesn't mix between a section, so minimize the slippage between a section of the liquid. And that is achieved in our meter through what's called capillary seals. At any position during a measuring cycle, the meter body, the blocking rotor, and at least one displacement rotor creates capillary seal, continuous capillary seals. And at any point of that cycle, there are at least 3 seal points preventing a liquid from moving from section to section. So unmetered liquid and metered liquid is separated from each other. Again, that's one advantage of this design. And obviously, when we're dealing with a capillary seals, means we're not dealing with metal on metal seals. Extremely important, because that, again, if there's no metal on metal contact inside of the meter, now we're looking at no extensive wear to the meter. If there is no wear, that means there's no increased clearances inside of the meter. If there's no increased clearances, no increased slippage of the liquid through the meter, which again ultimately means accurate measurement and measurement that doesn't require often calibration. So no deterioration in accuracy of the meter over time. In the next video, I want to show you guys that continuous seal. Please disregard different colors in this video because they are irrelevant. We want to really focus on positioning of the rotors in relation to each other, in relation to housing, and creating a capillary seals. So again, I'll put one more time this in motion. And we'll try to pause this at random point and look at generated seal points. So again, you can see again, disregard the colors, and we'll just pause it right now. Again, random point, we'll look at the seals. First seal, capillary seal, is gonna be right here between a blocking rotor and a housing. The second seal point is gonna be between a blocking rotor and displacement rotor, and the third one between a displacement rotor and a housing. Again, that allows us to keep this section of the liquid separated from this section of the liquid. And let's do it again. And at random point, let's stop this. So again, seal point right here, seal point right here, seal point right here. The liquid entering the metering element and liquid leaving metering element are separated from each other through the capillary seals between components of the meter. Now, design of LC meter is unique comparing to a lot of meters, a lot of technologies. One main thing is that we are really doing a true measurement of a liquid that's being displaced through the meter. And that movement of that liquid and rotation of the blocking rotors is directly translated into the volume. In case of our meter, then the blocking rotor turns, that blocking rotor drives the rotation of a blocking rotor is transmitted to outside of the meter, either through the packing gland. You can see it on this picture, little gear, the round plate and a gear. This is a packing gland assembly. And we'll look at a packing gland in a second. The second option will be transferring that motion of the displacement rotor, blocking rotor through directly to pulse output device or POD and sending a signal to some electronic register or flow computer. Again, the blocking rotor turns and then the rotation of the blocking rotor is transmitted outside of the meter through packing gland or pulse output device. Now, something that we're going to cover a little bit later when we talk about a calibration, but we talked about the rotation of a blocking rotor and that every rotation of a blocking rotor would display same amount of volume of liquid. If you look at, let's say, our M7 meter, 2-inch meter, it takes about 5.55 revolution of a blocking rotor to displace 1 US gallon, which means it's about 0.18 gallon per each revolution of a blocking rotor. That displaced volume will change depending on the size of a meter. Larger the meter, more volume is being displaced per each revolution. Again, that's going to be a part of a conversation later on when we cover calibrating of the meter. Now, let's take a look briefly at a packing gland. A packing gland, and there is just an example of 2 of them. Packing gland consists of, on one side of a drive, and on the other very end is a gear. The drive side of that packing gland, in this case, we call it a fork drive. We also have packing glands with a blade drive. They're in current production used on the larger meters like M60 and M80 and MS meters. The rest of the meters current production use a fork style packing gland. That fork drive will directly engage with the blocking rotor inside of the meter. Now, so as the blocking rotor turns, the packing gland turns. Then after the fork drive, we have a shaft that goes to the body of the packing gland, and on the end of it, we have a gear. Those gears come in different sizes. Again, that will be part of a conversation more during calibration, when to use which size of a gear, and what does it really means for calibration. The packing gland is designed to maintain or contain a pressure inside of the meter. So this is the pressure side of the packing gland shaft and a gear which is on outside of the meter. Along this shaft, you can see a little bit of a cross section. There is a seal called UCAP seal that it's a dynamic style seal that seals around the rotating shaft and against the body of the packing gland. This packing gland's got a little bit larger UCAP seal. It's designed for LPG, for higher working pressure, but the principle of operation of that packing gland is exactly the same. So again, packing gland transfers the motion of a blocking rotor to outside. Then normally you're gonna have what we call a phase gear that's gonna mash or engage with a packing gland gear. And in case of electronic registers, you're gonna have a just drive shaft going directly to the electronic register. In case of mechanical registers, you could have shaft, calibrator, or adjuster, and then going into the mechanical registration. More things about the performance and design of the meter. Again, register is designed, or sorry, meter is designed to measure accurately liquid in all kinds of conditions. Because of that seal area, we talked about the capillary seal. The seal area is very small and the slippage is minimal. The seal area allows us to maintain low differential pressure across the seal and across the meter, which helps us to maintain wide accuracy range in a whole range of operation of the meter. So for example, M7 meter for petroleum product is rated between 10 gallons, US gallons to 100 US gallons. Because of its design, we're capable of maintaining accuracy of the meter across the full range of that meter. Same thing with a pressure fluctuation. We talked about dual case design. We have external covers on our standard aluminum meters. We have welded vessel around our steel case meters. Again, that design allows us to maintain equal pressure across the internal components of the system, of the meter. So even changing pressure, the fluctuation of the pressure do not cause distortion of the components of the meter. They're not being stretched because of a changing pressure. And again, that even with that, changing pressure, we're capable of accurate measurement. The next one will be a temperature. The meters are designed in generally, all the components within the meters are designed with very similar coefficient of expansions. So as the temperature changing, again, coefficient of expansion of the components is very similar. That means they expand and shrink with a similar ratio. That allows us again to operate that meter in a fairly high range of temperature. Generally, the standard meter is rated for 40 degrees Fahrenheit, which is minus 40 degrees Fahrenheit, which is also minus 40 degrees C, all the way to 160 degrees Fahrenheit, which is plus 71 degrees Celsius. That's our standard meters. With additional components to the meter and additional precautions that we can take and designing a system, we can run that meter in much higher temperatures if required. You're going to see applications when those meters are being used on things like liquid sealers or asphalt, where the temperature of operation is way above 200 or 250 degrees Fahrenheit. Again, if the system is designed properly, the meter is going to operate in those kind of temperatures. And the last but not least is the viscosity. Because of, the profile of the flow of the meter inside is smooth and there's no really a compression or vacuum being created, we can operate that meter on the liquids that are varying viscosity in a fairly wide range. For something that is fairly thin, like 25 centipoise, all the way to 300,000 centipoise. And again, as you go through, again, selecting and designing a system, all this information has to be known up front in order to select the right meter and design that system around this kind of parameters. Now, I'm sure there will be some questions regarding all this, but I want to move on to the second part a little bit, which is we have this meter. How do we make sure that that meter operates in a long range, a long time, in really a trouble-free? And this is really comes down to 4 points. First, selecting correct meter for application. We don't make one meter. There's no one meter that fits all the application. There's not one set of accessories that fits one application, not one register that fits all applications. So it really, but it starts with selecting a proper meter for the application. And I know our sales guys will have a longer training on that, going over an application. I will just touch on a few things that I think are crucial to this part. Second, proper installation and a startup. Again, we'll focus on the main points here. proper operation and maintenance. From a meter selection standpoint, again, you cannot select right meter without asking right questions. I work in technical support. I get calls and with questions about, you know, what meter do I use? Can I use this meter? I bought this meter. Can I use it on certain applications? You cannot really know that unless you know a little bit more about the application itself. And here at LC, we have 5 basic questions, and anybody who starts working at LC, that's probably one of the things that hears a lot. Five basic consideration in selecting a right meter: product, flow rate, pressure, temperature, and viscosity. And that's not the only questions. There's going to be a lot more questions relating to the applications, but those are the first 5 basic questions that need to be answered in order for me to tell you which meter you need for your application. And I'll just very briefly cover all those 5 points. A product, what product are you flowing? Is this the only product you're flowing, or are you flowing multiple products? What is the, what is the future application? Are you going to be adding a product in the future? We want to make sure that all those questions are answered. So when we put a meter in service and it works right, basically the product will determine the metallurgy of the meter. What is this meter made out of? Is this going to be aluminum meter? Is this going to be a stainless meter? What kind of internals is going to have? What kind of rotors, bearing plates, and gears is going to have, depending on the application, depending on the product that's going to be metered. In our nomenclature, we use terms meter classes, which means we build meters for specific applications, and we just call those application classes. I will not cover each and every application. That's going to be a future training. But for example, just one class 1 meter, probably one of the more common meters that we sell and being used on the field. Class 1 meter is designed generally for refined petroleum products. So if you're measuring gasoline, diesel, heating oil, glycol, kerosene, some of the lighter motor oils, this is going to be a class of a meter that you would use. Again, different application, different class of meters. And again, I'll scroll through some of them: class 1, 2, 3, 4, 8. Again, there is a fairly long list of different classes of meters that are designed specifically for application. But again, future training will cover details of that. Flow rate, again, very generally, flow rate will determine size of a meter. If you are flowing product at 50 gallons a minute, or if you are flowing products at 800 gallons a minute, you're going to probably need a different size of the meter if that's your maximum operating flow rate. So it is important to understand what output you're getting in your system. What flow rate do you want to flow? What is your pump putting out? There are some other consideration that would determine the flow rate, which is viscosity and a product you are flowing. But generally, the flow rate is related to a size of a meter. Pressure, another important consideration. Our standard meters that we call M series meters, so like M7, M15, M30 meters. The standard operating pressure for those meters is 150 psi. But if you move to application LPG propane, that's a high pressure application. And the meters that you're going to be using is generally MA series meters. The A after M stands for higher operating pressure. In this case, it's going to be a pressure of 350 psi. So standard M series meters, 150 psi. MA series meters, you're looking at 350 psi. And if you look at our MS meters, again, they're also designed with a different pressure capabilities depending on the size of the flanges on those meters. So again, product, flow rate, and a pressure. Temperature, again, very important component of the system. Temperature will determine generally the seal material. The seals are at least they have ratings for a specific temperature. Buna is one of the common seals that we use that's rated between minus 65 to 250 Fahrenheit. So if your Vitan has a little bit little higher temperature on the lower end, minus 20 degree Fahrenheit. So again, when you are putting a meter in a specific situation, specific application, the temperature of the liquid, ambient temperature, all that is going to have to be considered to make sure that everything works correctly. Vitan, for example, if it's put in a temperature that's too low, gets a little bit more of a brittle and hard, and it's not going to seal correctly. So in a lower temperatures, Vitan might be compatible with a liquid, but it's not compatible with the temperature of operation. In some cases, when we're operating our meters, above 160 or above 200 degrees Fahrenheit, we have to take other precautions. We have to use extensions for our counters. We might have to use some oil jacketing or steam jacketing to keep the meter warmer, keep at the same temperature as the liquid. So again, a lot of consideration. This is just a note, but again, future trainings will definitely elaborate a little bit more on those parameters. And the last one is a viscosity. Viscosity generally is defined as a resistance to flow. So a more viscous product is more difficult to flow that product through the system. And again, higher viscosity generally generates higher pressure loss. So again, we have to make sure we specify the right size of a meter for that viscosity. And of course, the flow rate will be another consideration. So once we select the right meter and for our application, we want to also make sure that meter is installed properly. Mounting arrangements. If you look at this drawing, and it's very simple, and it's our manual, this is probably a most common position of installation of our meter. But that's not the only position that's the meter can be installed. Those two next also can be used when the inlet and outlet is in a vertical position. And even we can take that meter and put it upside down. As you can see, we can again increment that meter as long as we maintain that meter in that one plane. So depending on the application, depending on the needs. One thing we don't want to do is we don't want to install the meter laying on its back or laying on its front. That's something that's not going to help the meter work properly. But any of these configurations of those three configurations are allowed and acceptable. I'll cover a few main other points related to the installation. Obviously, the obvious things like making sure the safety precautions are being taken. Often you have to worry about local regulations, how you install the meter, all that has to be taken into consideration. Make sure that meter, but also the whole system is flashed out of any type of a debris. Often the meter will have a strainer that's going to catch some of this debris, but the fine stuff may not be able. So make sure the system is flashed. As simple as the LC meter is as in design, it is a very precise measuring device. Internal clearances are very small and very tight. Debris going to the meter will cause the damage, will cause the meter to lock up and stop operating properly. Never hang the meter on a piping. What it means that's when you're installing the meter, ideally you install the meter on with some type of a support and then run a piping away from the meter, not the other way around, but install the meter on a support, on a base, flat base, and then run a piping away from that meter. That piping also has to be supported. So the meter is supported, but the piping needs to be supported. With a 2-inch meter, maybe piping is not really heavy, but when you get to a 6-inch meter, the pipings can be obviously gets a lot bigger and heavier. Any kind of a stress put on a meter, either due to hanging meter on a piping or really a stretching the meter due to weight of the piping, will cause possibly changes of internal clearances inside of the meter. And as soon as we change those clearances inside of the meter, because we're stretching that housing, that will cause, will have effect on accuracy of the meter, but also possibly, again, locking up the meter if those clearances get too tight. The last point on that screen talks about installing a meter in relation to a pump. And that question comes up very often. A meter should be always installed in a discharge side of a pump, on a discharge side of a pump. You don't want to pull a product through the meter. You're going to have two problems. First of all, you're not going to be able to maintain that hydraulic balance we talked about earlier, and you're not going to be able to maintain meter full of liquid. So you're going to affect accuracy of the meter, but also operation of the meter, because there is no hydraulic balance of the meter, and you have possibly high differential pressure across the bearing plates. That's going to cause deflection to the bearing plates, changes clearances, and again, ultimately might damage the meter. So if you have a situation that you have to pump a product through both directions through the meter, which happens in some application, like let's say aviation, or if you're in that situation when you're receiving a product to the tank and then pumping from that tank through the same meter, you have to redirect the product through the piping and through the valve system to make sure the meter is always on a positive side of the pressure, on a discharge side of the pump. This is just an example of the installation that was not proper. Obviously, that the one thing that you can see missing is that there's no support for the meter. The meter is hanging on a piping, and it shouldn't. The pipe is nicely supported. You can see that there's a support for a pipe, but we could really use support for this meter. I usually get those pictures from a customers when something doesn't work right, and obviously this meter not being supported properly was resulting in proper operation of the meter. A few other things that in my opinion are extremely important from installation: always position meter in service with service in mind. Unfortunately, that rarely happens, and doesn't matter how much we talked about it, but it's usually people that service the meter are not people that install the meter. But if you are installing a meter, think about the future. How are you going to be able to access the meter? How are you going to be able to access the accessory? How are you going to be able to isolate that meter if needed from rest of the system if you have to work on it? Strainer generally is a requirement. We want to make sure that we protect that meter, and we'll talk about strainers a little bit more when we talk about accessories, but having a strainer, having in some cases a filter is important protection for the meter. Again, making sure you have a right meter for the application. It is important, and again, if there are any questions, if this is a right meter, again, contact our distributors, contact us directly if you have a question or doubts if the meter that you have is right for the application. Meter operation. Once the right meter is installed and installed properly, you want to make sure that it operates right. And there are a few things in a system that will cause the problems. One, again, keeping meter full of liquid. We already talked about this a little bit, but again, keeping a meter full of liquid is the key to a proper operation, to accurate measurement and longevity of the meter. So when you're designing a system, you want to make sure that that meter is full of liquid. So maintaining positive pressure always. Making sure that there's a valving system, check valves that keep the meter full of liquid at all times. When you're dealing with let's say delivery trucks, when you empty the tanks, or if you're emptying transports, you're always going to be introducing air to the system. So again, designing the system to make sure that we prevent that air from going to the meter. Now that will take possibly the air eliminators, valves, strainers, all that will be important. But again, we have to design a system that prevents air from going to the meter. The air has to be either A, not introduced to the meter whatsoever, or B, we have to be able to sense that air in the system, eliminate the air from the system before it goes to the meter, before it goes to the meters. The other thing we have to consider also are temperature changes. In some of the fixed terminal installations, the run of the pipes may be very significant. The pipes may be running for miles. And so the layout of the piping will be important, taking in consideration that the product will shrink, let's say when the temperature drops, creating a voids in the system. And again, putting a pockets of air in the system, we have to make sure we deal with this and design a system properly so that air doesn't go through the meter. So keeping a system full of air. Preventing hydraulic shock. Hydraulic shock is to some degree always going to be present in the system. In a very basic terms, hydraulic shock will occur when the liquid is moving through the system with a high energy. Now, if we shut down the valve downstream of that meter, that energy is going to come to, or the liquid is going to come to sudden stop. But the energy of that liquid is not going to dissipate. The energy of the liquid is going to work itself backwards towards the meter like a wave in the ocean. And that energy of the liquid is going to hit the meter as the meter is turning opposite direction. So the pump is turning the meter, and then energy of that hydraulic shock comes from the other direction. That's going to bring the meter to very, very sudden stop, and that spike of a pressure can cause all kind of damage to the meter. So really designing a system that prevents hydraulic shock is important. And that relates to a piping, a flow rate, pumps, specific valves. Make sure we open and close the flow in a gradual way. In some cases, when the shock is unavoidable, maybe having a shock absorbers in the system, either the bladder type or stand-up pipes that will absorb the shock before it reaches the meter and causes the damage, because the damage is going to be significant. This is just an example of a meter that was introduced to hydraulic shock. What you're going to see here is this is just the rotor coming through the bearing plate, and you can see what happened to that rotor and the keyway. The gear is completely off, and part of that rotor is broken. This is a result of hydraulic shock, means bring the meter to very, very sudden stop, and all that energy was, again, it's not going to dissipate, it's going to hit a meter, in this case, breaking rotor. Once the rotor breaks and the gears are off, well, that generally meter will lock up and there will be some significant damage internally. This is the same meter, and just the surface of that housing, when that meter went through that hydraulic shock and the rotors were broken, it's completely locked up. It kept turning and just scoring the housing. There's really nothing you can save on that meter. The third component is as far as the operation that we try to avoid. So we try to avoid meter being empty, hydraulic shock, and the third one is a thermal expansion. You can look at this document and copy on it a little closer at your own time when you look at through the presentation. But thermal expansion occurs, obviously the liquid will expand anytime or shrink anytime the temperature changes. But if you take a liquid and lock into the section of a system, let's say piping, a meter, and you fill that section completely with a liquid and lock it in there by closing the valves without any relief, the rising temperature will cause that liquid to expand. But if there's no room for expansion because that section of the system is already full, that will cause a rise of pressure. from a testing that has been done, we know that as far as petroleum products, if the temperature rises by 1 degree in that kind of full system, the pressure will rise about 70 psi. So per every degree Fahrenheit, temperature will rise about 70 degree psi. Now you can do your calculations. If the temperature rises 20 degrees, how big the rise of a pressure will be. And so that's why when we know that this is going to be a possibility in our system, we have to design a system to provide either internal reliefs back to the storage tank, or if there's no way of providing internal relief, to providing external relief to reduce that pressure. If that pressure is not reduced, again, it will keep rising as long as the temperature rising, and eventually something in the system is going to give. This is an example of M30 meter. This meter was operated at night. This meter was operated at night, not used during a day. So after pumping the product at night, the valves were closed and liquid was isolated in that meter and a section of the piping. Well, during a day, with the sun, temperature started rising rapidly, and I don't know exact numbers how much difference was in temperature between night and day, but it had to be significant to the point that eventually what you see here is cover of the meter cracked, obviously causing external leak. So again, very damaging to the meter, and really avoiding a thermal expansion and dealing with thermal expansion is really important. Couple other things before I close off and hand over to Juan is a few other operating requirements. Again, designing a piping to prevent air coming into the meter is important. Calibrating a meter is important. Make sure that that meter is calibrated regularly, conditions with the specific pump, with a specific liquid, specific piping. All that is going to be important. Providing a means for calibration is important. It means that, yeah, when you install that meter, how do you divert the product, or how are you going to be able to calibrate that meter going forward? So again, a few other points, but again, they generally relate to the air. Startup and operation. So again, we install the system with all this in mind. How do we start up our system? One word that comes to my mind is slowly. So prior to the meter startup, we want to make sure the meter is installed properly, secured properly, everything is tight. And then we start with closing all the valves. If we're pumping, let's say, from a storage tank through the meter and loading a transport, so let's use that up as a situation. We're going to start with opening slowly valve at the tank, and we're going to slowly flood the system and flood the meter. Keeping a valve downstream of the meter closed. So the liquid fills the meter gradually, and you can see the register possibly turning as the liquid is filling the meter. That also will give us time to eliminate any air in the system. So if meter is equipped with an air eliminator, once the meter stops and it's not turning anymore, we'll know the meter is full of liquid. At that point, we can start opening gradually the valve downstream of the meter, allowing a flow to the meter. Our general recommendation is that, again, you don't open that valve quickly, you open it gradually. Maybe initially you let it run at a fraction of the full flow before you start ramping up and increasing a flow rate to its full capacity. The startup can happen one of two different ways. We can either do it through gravity, if possible. That's going to be probably ideal situation when you just let gravity flood the meter, flood the system, purge the air from a system. If the gravity option is not possible, doing with a pump pressure will be it will be acceptable also, as long as we keep the main steps the same. The last and not least is a maintenance of the meter. The maintenance, in generally, our meter doesn't require any maintenance. I do get calls occasionally saying, hey, what is the maintenance, scheduled maintenance? How often do I need to do anything with the meter? In generally, the meter itself doesn't really require anything. There is no lubrication, there is nothing that you need to do to the meter. The few things that you will have to do is, first of all, if you putting meter into service, you're gonna have to calibrate. And then you're gonna calibrate as often as it required. We'll cover the calibration in the future. We'll talk a little bit more about intervals of calibration, but the meter has to be calibrated as often as it required. If you have any leaks, fix those leaks, because they're never gonna get better, they're always gonna get worse. If you have a strainer, that's probably one maintenance area that you have to do regularly. Keep the strainer basket clean. If the strainer basket fills up, eventually it's going to start restricting our flow. If that strainer basket, because of the high differential pressure, eventually bursts, will allow all the debris caught to go through the meter and probably damaging the meter and anything else in a system. And the last one is a seasonal storage. Some of the meters are not being used throughout the season. They may be used only periodically. One application that comes to my mind would be NH3 and anhydrous ammonia. They are used in for a short period of time during a season. Some meters are not used regularly because of other reasons. So we want to make sure that meter is stored properly. We want to make sure that there's no water inside of the meter. So ideally you drain the meter if possible, take the meter out of the system, drain the meter, clean the meter, and fill up with a liquid that's compatible with that meter that will prevent corrosion. Some of our meters have sintered iron gears, sintered iron bearing plates. They will corrode if water is introduced. They are not made to run on the water, so if the water is inside of the meter, the components will corrode. So storing it in off-season and draining them, filling up with the compatible liquid is the best way to go. If the meter is still in the system, you cannot take that meter out of the system. Again, make sure it's full of liquid. If you're running diesel, make sure it's full of diesel, and maybe occasionally recirculate the product through the meter and through the whole system. That definitely will keep everything nice and clean and prevent any type of accumulation of possible moisture and corroding. I think that will be about it for me. If there are any questions, please post them on the chat. I know Jeff is answering some questions. If there's anything that requires a little bit of broader explanation, we'll probably come back on the end of the training and do that. And with that, we'll take a quick break. We'll switch from the presentation view to camera view, and we'll hand it over to Juan.
Thanks again, Tom. Hey, while we're doing that, if anybody has any questions they want to ask real quick while we're switching over, feel free to, I'll do my best to try and address it while those guys are switching over. You'll have to just unmute yourself. If you're not comfortable asking a question too, please feel free to just chat it off. Again, there's a little chat bubble up at the top of your screen. Just click that and type away, and I'll do my best to address your question that way.
Hey, Jeff.
Hey, Pedro.
Hey, just want to make a quick comment. When Tom touched on the subject of relief for handling like potential thermal expansion, obviously the most common way to do that is to obviously the valves to be outfitted with the relief function.
Mhm.
And usually, obviously, the most common is, especially like in a loading type application, where you're transferring from the tank to mobile tanks, etc., is to go from downstream to upstream, right? So if there's any pressure to be relieved upstream towards the pipe, getting into the tank, if you will. So just wanted to mention that. That's just a practice that I've run into and the customers do in my end.
Great. Thanks, Pedro. That's a great point. Appreciate that.
Hi, this is Dave Cox with Tico Products. I had a question on the packing glands. I've had customers ask me if they can replace the U-cup seals and the O-ring rather than replacing the whole packing. And I could never seem to find a part number for those two parts. As they're not numbered in the breakdown. Are those available, or do they have to replace the whole packing gland?
I could probably answer that, Jeff.
Yeah, go ahead, Tom.
Yeah, first of all, we need to know which packing gland that is, right? Because not all the packing glands are created equal. So is it a Vitan packing gland? Is this a Buna packing gland? And is it an LPG packing gland? Because the UCAP seal will be different. So we need to know which one that is, and we can find the parts. You can change them absolutely. I'm pretty sure they are sellable. They might be sellable in the packages of more than one, but they are sellable items. And they're fairly easy to change. As long as we know which packing line you have, we can find you right parts.
Thanks, Dave.
I don't.
Hey, this is Weston from Rampmaster.
Hi, Weston.
I had a quick question for you. If I understand correctly, the product going through the meter is in the meter area as well as on where the gears are at, that are the blocking gear and the displacement gears. Is that correct?
Yes, it is.
Okay. So do you ever see much wear on that side of where the metal's contacting metal for the gearing, or is that not really an issue?
I mean, obviously because the gears are submerged in a liquid that provides automatically lubrication for those gears. And in normal operation, we don't see a lot of wear out. Where you're gonna see a wear out more often when you're dealing with a hydraulic shock. When hydraulic shock occurs, then again, those gears come to sudden stop, and you will see the gears wearing off. Normally, each tooth on the gear has like a flat top. When you start seeing those teeth getting a little sharper or more pointy, that's usually a result of hydraulic shock. Otherwise, if in a normal operation, we don't see much of a wear on those gears.
Okay, thank you.
Hey, Tom.
Yes.
Okay, this is Pedro. So just wanted to make a quick comment / question also. Don't you also see some of the sharpening of the teeth and the gears when the meters, like after they're stopped, the product drains, and so you have air, and so when the pump starts the next day or so, the liquid is pushing the air, and then it's like literally over speeding the meter with no lubrication. Isn't that the case also?
Sorry, I was muted for a second. Absolutely. I mean, running meter on air is never a good idea. And you're gonna see a wear out everywhere. That's why, again, I don't know how many times I did already, and I'm sure everybody will emphasize that running meter full of liquid is the key. When you're running meter on empty, the meter will spin freely on air. So if you don't have a means of stopping air from flowing and eliminating, you're gonna have a problem sooner or later. Because again, now you're not maintaining a balance, hydraulic balance inside of the meter. Gears will be wearing off more. And obviously that the rotors will not be as centered as they should be with an equal pressure. So now the rotors maybe start scoring against the bearing plates. I mean, running on air is never a good option. Whatever you do in your system, you have to design that system that stops air from going through the meter and never run that meter on air. That's
Great. Thanks,
And
Tom.
that- yeah.
Go ahead, Pedro.
No, I was just going to say, and then with the corresponding potential damage later when the liquid arrives and you have this sudden break on the rotors, right? So just throwing that out.
Thanks, Pedro. Sorry, we're just having a little technical difficulty getting the camera up here. So I'll be back with you in one moment. All right, sorry about that. All right, we just had to get the camera working here. Hopefully, you guys can all see. Pedro, just let me know. Are you seeing the camera or the camera view right now?
Yeah, it's a good shot. We're good.
Great, thank you. All right, so again, we're gonna at the end of this presentation here. So we're gonna jump over to the live demonstration of the meter here itself, as far as repairs and breaking down the meter. But once we're done with this, if you have additional questions at the end, we're gonna hang out online here on the Teams meeting as long as there's questions. So please don't shy away from that. Just know that we're here. But with that, I'm gonna hand it over to Juan and let him take over.
All right, how's everyone doing? Before starting to disassemble the meter or working on the meter, we always recommend for you to review the M-M8 meter. Also, you can find this, if you don't have a copy of this manual, you can also find it on our website, lcmeter.com. Under resources, and just look for the manual and review it for any before you start any working on any meter. Also, we highly recommend looking at it to make sure your torque sharp before you assemble the meter again. We'll show you this shark further down, but we highly recommend you reviewing the manual before you start working on the meter. Also, for this demonstration, we took the meter off. We're just showing you the meter. It's off the piping, but before removing the meter from the piping, always make sure that you isolate the meter, close any valves that are putting pressure on it. Once you close the valves, isolate the meter. relieve the meter from all pressure. Make sure that you have zero pressure going to the meter. And then we'll start by disassembling the meter once you have it isolated. We'll start by removing the drain plugs. Make sure you remove front and back drain plugs to empty the meter. Relief of all pressure. We'll do front and back. This is always done so there's no product inside the meter once you open the covers. You avoid any spillage, any accidents. Once we know our meter is empty and it's got no product, we're gonna start by removing the bracket. We'll use a 3/8 socket or wrench. Well, 3/8 socket. It's gonna make a little noise. Hopefully, it's not too loud. There's 4 3/8 hex screws. Using an extension and our 3/8 socket, we'll remove all four screws. To remove our bracket. Make sure we keep them together so we don't lose any screws. After removing our bracket, we're gonna remove our packing gland. Using a 5/16 socket or wrench, we're gonna remove our screw. There's 2 hex screws. We're gonna remove our hex screws, and we're gonna remove our packing glands straight up. Make sure always once you remove it, always make sure that your O-ring is not damaged. Still good, and we put them together with the screw so we don't lose them. And then when we're trying to put it back together, we're missing a screw. After removing our packing gland, we're gonna start by removing our front cover bolts. We're gonna start in a crisscross pattern, and we do this so we don't put any stress on the cover and we don't warp it. Sorry again for the noise. And I can stress this enough. We do this in a crisscross pattern, so there's no stress on the cover, and later we don't have any leaks. Try to use something to keep all your bolts together, so that way you don't misplace them. Once we unscrew the bolts, we're gonna remove our cover. Always make sure that your cover is good, no damage to it, it's not warped. We're gonna put it aside. After this, we're gonna start by removing our timing gears. We start using try to use a spare gear if possible. If you don't have a spare gear to lose this bolts, you can also use a shop rack, and we use this to keep the gears from moving when we are loosening up the bolts. This is a hex screw bolt for our blacking rotor gear. Once we lose and remove our bolt, try to keep it together with our packing gland driver. Next, we'll loosen up and remove the our displacement gear bolt using a 7/16 ratchet or socket. Of course, this looks easy because, well, we're using a new meter, hasn't been in service, clean gears. Again, try to keep your bolts and your own washers together. And like I said, this looks easy because it's a new meter. Out there, you're gonna find meters, of course, they've been in service and maybe with corroded or frozen gears. They will give you a little bit of trouble to remove. Once we lose and remove our bolts, we're gonna start by taking our gears off. I'm gonna be using 2 flat blade screwdrivers. And what we do is we put them underneath the gears, or if you only have one, what you can do is put it underneath where the wardrobe key is and pry it up. Make sure that you don't pry it up gently. Make sure that you don't put too much stress on it so you don't damage it. Once we lose up, make sure you keep the wardrobe key together so we don't lose it. And we'll do the same on the displacement rotor gears. Again, if we only have one, then we do it on the where the key side is, and we pry it up gently so we don't damage it. Again, like I said, this is a new meter. We're not fighting with any corrosion, any frozen gears. But if you find a meter with corroded gears or frozen gears, you can also refer to the manual, to the M-MA meter manual to remove the gears. One thing that you can do if you are in that situation is continue with the disassembly, remove the back cover, and then gently with a plastic hammer or rubber mallet, hit it gently, hit the rotor shaft gently, so you loosen the rotor from the gear, and you're able to remove it. But you can also, like I said, you can also see the manual for more instructions on how to remove corroded or frozen gears. After we remove our gears or timing gears, we're gonna remove our bearing plate hex screws using a 5/16 socket or wrench like the one we use for a packing gland. We're gonna remove the screws. Again, we want to do this in a crisscross pattern so we don't put any stress on the bearing plate. Once we loosen and remove our bolts or hex screws, we're gonna again use 2 flat blade screwdrivers to remove the bearing plate from the housing dials. I'm gonna move this aside and hopefully you can see it. Maybe I can lift it so you can see better. There are 2 notches on each side of the bearing plate where you can place your screwdriver to pry it up. Make sure when you're doing this, you do it gently. So you don't so you don't damage the bearing plate and the housing at the same time. You don't warp it. Once we remove it, always inspect the bearing plate. Make sure that there's no wear and tear, no damage. Look for flatness, and to look for flatness, you can also use a blade with a flashlight. I'm sorry, and look for any warps on the bearing plate. Put this aside. After we remove our bearing plate, we're gonna remove our O-ring. Very important to inspect the O-ring. Make sure that it's not damaged. It's still good to be reused. If you're using an O-ring, either Buna O-ring or Byton, you can. If it's not damaged, no nicks on the O-ring, you can reuse it. If your meter is using a gasket or a Teflon O-ring, we highly recommend to replace it, so you can have a even seal when you putting it back together. At this point, we can remove our rotors. Gently, we slide them up. Always inspect that there's no damage on them, or if it's damaged, depending on why are we disassembling the meter, always inspect your rotors. Make sure that they're in good condition. Make sure for scoring, wear on the rotors, that they still good. Once we removing our rotors, we'll turn it around and we'll remove our back cover bolts, back cover screws, using a 1/2 inch socket or wrench. Again, we're gonna start doing this in a crisscross pattern, so we don't put any stress on the cover. Once we loosen and unscrew our bolts, we'll remove our back cover. Again, making sure that it's not damaged, it's not warped. So when we go back to assemble the meter, everything fits in place correctly. We'll continue by removing our bearing plate hex screws. Again, using the 5/16 socket or wrench. And again, we do this in a crisscross pattern to avoid any stress to the bearing plate. Once we remove our hex screws, we're gonna use again the two flat blade screwdrivers. We're gonna pry up our bearing plate. Once we remove it, we're gonna inspect for damage on the bearing plate, any wear or warp. Always try to clean it so you can see better of any damage. That way, when you put it back together, you have your parts clean. So that way we don't introduce any foreign debris into the meter. Put it aside. We'll remove our O-ring to inspect it. Once we make sure that our O-ring is in good condition, we're gonna move to inspect the housing of the meter. See what damage we have, if it's something that we can fix, or if we indeed need to replace any of the parts. If we are disassembling the meter, it's because we find some damage, or either there's a leak or our meter is blocked, it's not turning. So once we disassemble the meter, we're gonna look for that damage, see what's inside. If we find any foreign debris, if our inside housing is damaged, it's got some scoring. If we do find any scoring in our housing and there's an emergency where we need to keep working, or we had to wait for the replacement, what we can do, and this is if the scoring or the damage is not too substantial, where you can fix it. What we can do in the meantime is, where our scoring is, we can shape, we can sand down the high points of that scoring, always using a light sandpaper or a acrylic cloth to remove the high points. Make sure you don't shave too much of the meter, because then you're gonna start showing slippage. You're gonna lose the capillary seal once we put it back together. Also, if you replace any internal parts, or if you shave any of the scoring and any of the high points of the scoring, we highly recommend to recalibrate the meter so you have a accurate meter. At this point, once you do your repairs, once you will be this done with our disassemble of the meter. Any questions before we start our second part? We're gonna pause it for 5 minutes to open up for questions.
Hey, Juan. Hey, this is Jeff.
Yes.
We had a question from Dave Cox here. Actually, this is more around a comment here. He was questioning about the O-rings, the front and back O-rings. He's saying that the front and back O-rings have different part numbers. Is that correct?
No, there's the same part number.
Right. Okay. And then in this case, he's also saying he's had customers say that not only have different part numbers, but one will be a gasket type material. Typically, again, with our meters, if you have an O-ring, not a gasket seal, it's going to have either gaskets or it's going to have O-rings depending on the vintage of the meter. But today's common meters are going to have O-ring seals on the front and rear covers. Tom, if you're in there, that's correct, right?
Yeah, that is correct. I mean, our design has changed over the years, and some meters have gaskets, some O-rings, but front and cover seals are always going to be the same. Either O-ring or a gasket. You could have a situation that somebody modified something on a field, used old housing, new covers, or the other way around, where we would possibly put a cover with a gasket on the front and cover with an O-ring on the back. It's all doable because those things generally fit, but it would be a probably field modification. Somebody did it in a situation they had to do this, but otherwise, new meters, they all have the same front and rear seals.
Great.
Anything
Thanks,
else?
Dave. Thanks, Dave, for the questions. Hopefully that cleared it up for you. Any other questions?
Jeff,
Yeah.
Kevin Nugent, would the different part numbers for the front and rear O-rings, isn't that one time we used a square O-ring design versus the round O-ring? Is that a possibility?
I mean, but that's still, in a new meter, there would be still the same thing. Yes, on M7, our seals have changed and we went from square to round O-rings and again, gasket in the past, but new meter will always have the same seal on both sides. Again, when it goes on the field, it can be replaced with something else possibly, but not coming from a factory.
And Tom, when we say in the past, I mean, we're talking, I don't think we've used square O-rings, in the last 20 years, is that correct?
That would be probably, maybe early 2000s, late 90s when we use a square O-ring. But again, they're the same size. They had a different part number, but they were the same size. So you could technically take the square O-ring and replace and put in place of a round O-ring and vice versa. They will fit.
Perfect. That was going to be my next question.
They will fit, but that's a field replacement situation, not necessarily a new build coming from us.
Great. I see a question got past me here from Sean here. Should you mark the gears for timing? And I think we're actually going to cover that coming up here. But if you want to make sure we address that one as we're going forward and reassembling the meter.
Yes.
Thanks. All right, so let's continue on and we'll open it up again for questions at the end here. So please don't hesitate or keep those questions coming. Appreciate it.
All right. We're gonna start by assembling our meter. Before we start assembling our meter, we're gonna first determine the direction of how we want our meter to be. Left to right, right to left. And we're gonna determine this by the bleed holes or the notch on the housing, but also the nameplate side of the meter. I know Tom talk a little bit about the bleeding holes and what they're for. So we always want to identify what side, for which side we want to build our meter. And this notches or the nameplate is always an indication of our inlet. So once we identify that, we're gonna start by building our back cover first. So
Left to right, go left.
So we're gonna do it left to right. This will be our back side. So our inlet, because it's our back side, will be on our right. And we're gonna start by setting our bearing plate into the dials of the housing. The dial pins of the housing, I'm sorry. Once we put them in place, we wanna make sure that this sits correctly and firm into the housing. So we're gonna tap it lightly so it sits right on the housing. And we're gonna put the hex screws, 5/16 hex screws. But always remember to put anti-seize compound on the threads of the bolts. So this is if in case that we need to disassemble again, we don't find any corroded or seize screws. Again, we're gonna do this in a crisscross pattern. First, we're gonna tie it by hand as much as we can.
Hey, Juan, this is Jeff.
Yes?
Is there a reason we tighten those by hand?
Well, because we wanna, these are self-tapping screws. We wanna make sure they're sitting correctly, that it goes in right, especially if this is a already built meter. So we want to we don't want cross thread it.
Thank you.
So once we apply the anti-seize compound and we tie it by hand, we're gonna look at our chart, and with the 5/16 socket or wrench, we're gonna torque it down. This is about 7 foot-pounds on each hex screw. And again, we're doing it in a crisscross pattern. So we have an even compressor on our bearing plate. Next, we're gonna install our O-ring. You always wanna make sure that you lubricate your O-rings. Make sure that, depending on your application, make sure that you use a petroleum lubricant grease. Or if it's, like I said, depending on our application, we also can use oil. If you're using oil, and I'll show you on the other side, we want to apply the oil first on the groove of the housing, and then install our housing. I'm sorry, our O-ring. On this application, this is a refined fuel meter. We're gonna install the O-ring, and then we're gonna apply a thin layer of our petroleum lubricant grease. This is to keep our O-ring in good condition, lubricating. Once we do this, we're gonna install our back cover. We put it in place. And we're gonna install our head screws, self-tapping screws. Again, always make sure that you apply a little bit of anti-seize compound to your threads. And again, we want to make sure that our head screws going correct. Since there are self-tapping screws, we don't want to cross-thread them. Once we have them in place, you always want to do this in 2 passes. So the first pass, and again, doing it in a crisscross pattern. We're gonna start by tying them down. Once we have them in place, our second pass should be to torque them down, and this would be about 66 pounds on each of the head screws. Again, we want to do this in a crisscross pattern so we don't put any stress on the housing. Also, to put a uniform pressure on the seal to avoid any leaks. And always refer to the chart on the manual for torque and how to do the crisscross pattern. Just at this point, you can also install the back drain plug. We're gonna tie it down with the 1/4-inch Allen wrench. Again, apply a little bit of anti-seize compound to the threads. You always want to apply the anti-seize compound to the threads to avoid any seizing. Once this part is done, we're gonna turn it around. And we're gonna install our front cover. So we'll start by putting in our rotors. We'll start with the blacking rotor, which is the big rotor, goes in the center hole, and always make sure that tape side goes up. Make sure that goes in freely, and then we'll install our displacement rotors. Again, making sure that our tape side is facing up. Try to install the vanes facing up.
Hey, Juan, can you hear me?
Yes.
Just a quick question. And sorry for interrupting. I know we're going to wait till later for questions, but when inserting the rotors, if you happen to have carbon inserts on the bearing plates,
Yes.
is it not a good idea to tell them to be careful in terms of inserting the rotor so we don't chip the inserts?
It's always a good idea whether it has carbon inserts or not. And also, we want to inspect the inside of the carbon inserts. Make sure there is no wear.
But bottom line, Pedro, you answered your own question. Yes.
Just trying to make a point. Sorry.
So
That's
once
what
we
sales guys
install
do,
our rotors, we're gonna install our bearing plate. Carefully placing it over the rotor shafts and into the dial pins of the housing. Again, if you feel like it's not sitting correctly, just gently tap the bearing plate to make sure that it sits firmly on the housing. Once this is done, we're gonna install our hex screws, 5/16 hex screws. Again, putting a little bit of anti-seize compound on the threads. Like I said before, we'll install this in a crisscross pattern. Try to screw in by hand at first to make sure they're going right. And then torquing down by the manual chart in a crisscross pattern. Again, it's about 7 foot-pounds, but always double check our manual chart. Hopefully I'm not going too fast. Everybody can tell how we installing it back, how we assembling it back. After we put our hex bolts and we secure our bearing plate, we're gonna install our O-ring. Like I said before, depending on our application, we're gonna use either grease or oil. If you're using oil, what we're gonna do is we're gonna put a little bit of oil in the groove, and then we're gonna set our O-ring. And the oil, we use it more on LPG application for low temperature products, or low temperature application, I should say. Once we install our O-ring and it's lubricated, we're gonna start by installing our timing gears. On our timing gears, before I install them, I wanna show you. They have this timing notch or marks, and we want to make sure that these marks are facing up, for one, and two, we want to make sure that we notice them because we wanted to align them with the second gear. We want to make sure they're aligned correctly, because if it's off even by a tooth, you're not gonna be, your meter could be off. You're never gonna be able to calibrate it correctly. So once we notice that, we're gonna start by putting our Waldorf key on the keyway, and we're installing our blacking rotor gear with the tape sight up. Once we install our gear, we're gonna face it to one of the displacement rotors, and we're gonna try to do it by placing by hand. Make sure that they're aligned, and so you don't have too much play when you go to install the second gear. Facing the keyway out, we're gonna install the Waldorf key. And then we're gonna slide in our second gear. Like I said before, make sure that the two notches are lining up correctly. And we will move to the second one. By hand, we're gonna try to place it again, our keyway facing out. We're gonna place our Waldorf key in, and we're gonna slide our second gear, making sure that the two notches, the two marks, are aligned together. Again, I'm gonna show you a little bit closer so you can see where the two marks are and how they should line up. Once all three gears are set, we want to make sure that they turn freely. We want to do a couple of rotations to make sure that they're not hitting anything. They move freely, and more important, that they are aligned the way they should. Once it's done, we're gonna tie them down, securing with our the blacking rotor comes with a packing gland driver. This I want to show you this driver because at the bottom it has a little key or notch that it should engage on the blacking rotor gear keyway to keep it in place. Make sure that it doesn't move.
There's only one correct position of it.
So we want to make sure, I don't know if you can tell, but we want to make sure that it sits the way it should. It sits right. And then before installing our screw, we want to make sure that we apply Loctite onto our screws. NSCs, I'm sorry, NSCs onto our screws. Again, we're gonna do this by hand. These are not self-threaded screws, but we want to make sure that we do it by hand. So when we install the other ones, it doesn't move before we torque it down. After, we're gonna start by installing the screws into to secure the displacement gears or down washer. Make sure the curve is facing down. Again, we do this by hand first. Same on the other side. And then to secure, we're gonna use our spare gear or shot rock to make sure that the gears don't move. So we'll start by securing our blacking rotor displacement, blacking rotor gear. I'm sorry. And we're gonna torque it down at per our manual shaft. Next, we're gonna torque down our displacement gear bolts using our 7/16 again socket or wrench. And again, we're gonna refer to our manual shaft for the right torque. Once this is done, we always want to make sure that our rotors are still turning freely. They're not hitting any high points. They're not getting stuck anywhere. Once we do this, we're gonna start by we're gonna cover the meter. We're gonna place our front cover. Our front cover is the one with the center hole for our packing gland. Once we put it in place, we're gonna put our self-tapping bolts. Again, making sure that we put anti-seize compound on our threads. And making sure that they go in correct. Because like I mentioned before, they are self-tapping screws and we don't want to cross-thread them. Once we do this, we're gonna do a first pass and a crisscross pattern. I always try to go for the next bolt, but try to keep in mind you want to do it in a crisscross pattern to avoid any stress and also to do a uniform compression on the seal. Once we do our first pass, we're going to refer to our manual for the torque shot. Again, in a crisscross pattern, and we're going to apply about 66 foot-pounds of pressure. Once this is done, next we're gonna install our packing gland. Again, make sure you lubricate the seal, inspect it, make sure it's still good, not damaged, if we're gonna reuse it. Like I mentioned before, if you have Teflon seals, you always want to replace them. So depending on your application, depending on your seals, you wanna inspect and either replace if needed. To install it, make sure that the fork engages inside the meter on the packing gland driver. And to do this, to make sure that it's engaging correctly, you can try to turn it by hand. You don't have to do too much, just a little turn. Also, you want to make sure that our packing gland flange is aligned with the housing to secure it with our hex 5/16 hex bolt, hex screws. Again, don't forget to apply anti-seize compound to the threads. Once we put them in place, very important to remember this. Refer to the manual for the torque, because these screws, if you go past the torque, you can break them easily. So you apply about 7 foot-pounds of pressure on these bolts. Once we install our packing gland and make sure that everything engages correctly and turns, we're gonna install our bracket. When installing our bracket, make sure that our plastic gear or face gear engages to our packing gland. It doesn't have to be very tight, and obviously not loose. It has to have a little play, because when we install our register, it's going to put some tension on it. Again, make sure we apply a little bit of anti-seize onto bolts. So we put them in place, and using an extension and a 3/8 socket, we're gonna tie them down. Again, we'll do this in 2 passes, crisscross pattern. First pass, just put it in place, make sure that our face gear and packing gland align. Make sure that it's not too much tension on it. And then we'll refer to our torque shock on our manual to torque it down. Again, in a crisscross pattern. Once this is done, all we have left is installing our drain plugs. Again, apply a little bit of anti-seize on them. Screw it in by hand and tie it down with a 1/4 inch Allen wrench. Once this is torqued down, this will conclude our assembly of the meter. Again, for any questions on the torque or corroded or frozen gears, always refer to our manual M-M8 meter manual.
I guess we'll open to the questions now. We're here, so if you guys have any questions, feel free, just unmute your mic and see if you can, or send us a quick chat with a question. We'll try to answer. I don't see anything coming across right now, at least in the chat area. Calibration. That is a great question, but the answer probably would be longer than we have right now. If you look at our schedule of our future trainings, we do have the whole 2-hour training dedicated to calibrating meters with mechanical registration and meters with electronic registration. That may be a little bit more time to answer all the questions and the details than this conversation. And I know this doesn't answer your question, but just please join us on the next, I think it's in June, session dedicated specifically to calibration. We'll answer all the possible questions back then. Will be a lot more time for it. If there's no other questions, I guess we'll conclude for today. Again, thank you for joining us. Looks like a lot of people joined. Thank you, Juan, for joining me in this. Thank you, Jeff, for directing behind the scenes the whole training. And thank you guys for being here and spending 2 hours with us. Again, please check your invitations. Please check the schedule for the future trainings, but this is something we're going to be doing on a regular basis. So we'll try to cover all the topics. If anything specific that's not on the schedule and you want to cover, just let us know. So thank you very much.
Thank you.
And I'll see you next time.
Next time. See you too. See you.
All right, guys.
Great job, everybody.
All right.
Thanks.
Bom, o vale no diâmetro teu. Esse metro teu. O bet dilim se li pou denye moun ki prale ya. Ya tout nek fin desan la desan. Kwe sou traitement desan. Traitement moun ne mwen kap desan. Wa mos genan desan. Même desan. O job desan tout. O dia desan. O dia desan. O bet va remonter parce que depuis j'ai ouvert il y a ça va.